All right. In this video, we're going to talk a little bit about exponential functions and their graphs. So taking a look at the screen right now, we've got an example up top. And what we want to do is figure out what is the graph of f of x equals 2 to the x going to look like. Now, again, this is not 2 times x, where we would just think it's a nice linear equation. We want to remember what exponential functions look like. And remember, for an exponential function to be exponential growth, right, if it's going to have a greater than 0, remember that we refer to this as exponential growth. Because as long as our exponent, right, is growing to the right, as x goes to 1 or 2 or 3, you might notice over here at the right, our numbers are going to get larger and larger. Because remember, 2 to the first power is 2. 2 to the second power, right? Essentially, that's what x is right now, is the power or the exponent, right? There's where we call it an exponential growth function, right? It's power function. So we're looking at this and saying 2 to the first is 2, 2 to the second would be 4, 2 to the third is 8. And really, if we let that keep growing, it's going to grow really, really quickly. When we talk about exponential growth, we're talking about really, really fast growth. So 2 to the 10th is already 1,000. By the time we reach the edge of this graph, we'd already have to be up at 1,000. And obviously, we're not going to be able to plot that, but we can definitely plot 1, 2, right, up here, 2, 4, and I think we can even get 3, 8 in here. I believe this is 8 if we count out carefully, counting by ones there. Right? So again, this was 2 and 4 and 8, and we're definitely increasing, right, as that graph grows. Now, we also want to remember a few other powers. Remember that anything to the 0 power is going to be a 1, so we can plot that point at 0, 1. We also want to remember that any negative exponents basically make fractions. 2 to the negative first power is just going to make a reciprocal. And basically 2 to the negative 1 is a 1/2. 2 to the negative 2 would be a 1/4, right? 2 to the second power was 4. Its reciprocal is 1/4. So notice as we go to the left, again, we're going to be at a half. We're going to be at a quarter. We're definitely getting smaller and smaller. And just like we said, 2 to the 10th is a very large number. Well, 2 to the negative 10 then is 1 over 2 to the 10th, or basically 1 over 1,024. So small, we're basically not going to be able to notice it. In fact, most of these numbers out to the left are going to be so close to 0, we're not really going to be able to do much about it. But again, that's essentially what an exponential growth function is going to look like. Now, the idea there is, as we go out to the left, we're getting closer and closer and closer to 0. But remember, there's also no exponent that 2 to a power would ever turn to the 0, right? 2 to the positives are big numbers. 2 to the negative numbers are tiny fractions. But nothing in the exponent is ever going to turn that to 0. So therefore, we have an asymptote, right, at y equals 0. So we're going to graph that, remember, with a dashed line. We're just going to draw a nice dashed line here right along that x-axis, basically just reminding ourselves that, again, at y equals 0, right, y equals 0 is going to be our horizontal asymptote, right? So we'll say HA there, horizontal asymptote. Out to the right, remember, we were getting larger and larger, but out to the left, we're actually going towards 0. It's getting closer and closer to 0 without ever touching. Let's answer a couple of quick questions, just a few things we want to remember about exponentials. So again, we just plotted 2 to the x. So I'm going to go ahead and plot, and I'm going to go ahead and go by halves here. So I'm going to call this a 1 right there. Remember that 2 to the 0 was 0, right? 0 went to 1. 2 to the 0 power was 1 power, or 2 to the first. 2 to the first actually went up to 2. And 2 to the second would have gone up to 4. So again, there's 3 and there's 4 up there, right? And again, we were at a half, we were at a quarter. Again, going to this side, there is, let's go ahead and label that 2 to the x, right? That's going to be in red there on our graph. Let's go ahead and go in blue for 4 to the x. Again, 4 to the first would already be 4, right? So it's going to be much higher there. So notice the questions over here at the right. For what values of x would 4 to the x be greater than 2 to the x? Well, definitely over here at 1. And really any number to the right of that, right? 4 to a power is going to definitely be bigger than 2 to the same power. However, 4 to the 0 is still 1. So what do the two graphs have in common? Well, one common point is definitely at 0, 1. But also 4 to the negative 1 is only a quarter. 4 to the negative 2 would be 1/16. So notice out here to the right, the blue line is actually below the red line. They're going to cross over at 0, 1, and then we're going to rise above there, right? Just a nice smooth curve there to the right. So again, when is 4 to the x greater than 2 to the x? Well, definitely out to the right of 0, but notice to the left of 0, we're definitely below, right? The blue line's below the red line. And what do the two have in common? Well, the point 0, 1, and of course also that horizontal asymptote. Notice they're both, right, not going to cross the x-axis. What if we did f of x equals 1/2 to the x? Well, remember that technically 1/2 to the x is the same thing as 2 to the negative x, right? Negative exponents, again, make reciprocals. So just like taking that x, right, and putting it on the 1, putting it on the 2, this would be 1 over 2 to the x, or basically 2 to the negative x. So we're going to get a very similar graph to what we had before. Now, instead of plotting a lot of points, let's plot 3 easy points just to get the basic idea of what's going on. Again, if we plug in 0, oops, not right there though, but if we plug in 0 for x, basically we're still equal to 1. So again, I'm going to go ahead and plot a point. I'm going to call this 1 here. I'm going to go ahead and go by halves here. If I plug in 1, again, I'm going to get 1/2, right? 1/2 to the first power is just a half. So over here at 1, we're going to be at 1/2. And really, if we plugged in -1, now I know that doesn't necessarily jump into our minds as an easy point, but remember, negative exponents make fractions. They make reciprocals. So 1/2 to the -1 is actually going to be 2. So what happened was, again, note negative inside the exponent, sort of like a horizontal reflection. We're rising to the left this time, but again, we're falling to the right. So therefore, again, horizontal asymptote still going to be at 0, right? No exponent's ever going to turn that to 0, so y equals 0 there. But if we think about the domain and range, I'm going to jump over there. Domain is infinitely left and right, right? There's all real numbers. There's nothing I can't plug in there. But the only answers I'll ever get back will be greater than 0. Even though it's a 1/2 x to the x or a 2 to the negative x. Again, I'm thinking about the outputs, right? 2 to a power or 1/2 to a power will always be positive. It's 1/2 times itself over and over and over again. It's still going to stay positive. And describe the end behavior. Again, the basic idea. Oh, we got a little extra end behavior going on there. Basic idea. To the left, we're rising this time, and to the right, we're falling towards 0. Right? We're going to level off at 0. Right. Let's take a look at one last thing as far as the basics of exponential functions go. Again, natural base e is the natural base of an exponential function. If you remember, e is 2.718 approximately. It's an irrational number. It's going to fall sort of in between 2 and 3. Well, that means that e to the x will just be sandwiched in between 2 to the x and 3 to the x. So if you notice here, 3 to the x is going to rise the fastest. E to the x is sort of in between, right? And then 2 to the x is rising the slowest. Still rising exponentially, but compared to the other two, it's going to be the slowest rising, right? Notice they're all still going through the point, right? 0, 1. But again, that e to the x sort of falls in between the other two. They all still also have a horizontal asymptote at y equals 0. So notice again, still not going to cross 0. Because e to the x is still just a number, right? E is still a number. It's a positive number, greater than 1. So it's going to cause that exponential growth, right? Speaking of that, remember, because this was a 1/2, we would have said that this, remember, was an exponential decay function. Because 1/2 is less than 1. It's between 0 and 1. Notice from left to right, that one's decaying toward the asymptote, right? Again, it's not rising away from it from left to right, it's decaying toward it. So we call that decay, whereas we would have called all these other graphs, right, growth. All right, I hope that helps you remember some of the details of exponential functions. If you want to see how these functions can move around a little bit, I'm also going to make another video on exponential transformations, right, function transformations. We'll just remind ourselves how things shift around or stretch or reflect on our graphs. If you have any questions, talk to your teacher. Otherwise, have a great day.